Okay, let's continue our discussion of organic chemistry. We'll begin with a brief review of what we've covered so far. Okay, so remember, carbon chemistry is organic chemistry. It all is based on carbon. And remember, carbon is in group 4A, right? Everybody should know that. You have a periodic table. Oopsie, my pen is starting up already. Okay, okay, so 4A is the right. 4, group 4A has carbon and silicon. Remember, that 4 tells us the number of valence electrons, and carbon is there. With the Lewis dot, we have 4 dots. Okay, in organic chemistry, we write it with lines, right? So we're going to do 4 single bonds. Later, we'll do double and triple bonds, but for now, we're just focusing on single bonds, all right? All single bonded carbons, right? These hydrocarbons, and again, we're doing hydrocarbons as we'll see. We're just adding hydrogen first. These are called alkanes. All right, so all single bonded carbons, the ending will have ANE. So if you're given on an exam a molecule, a long compound, and you see only single bonds, the ending must be ANE. Okay, and then we said the prefixes are determined by the number of carbons in the longest chain. Now, the longest chain, as we remember from the last lecture, is not always so easy. It's a little cryptic, so we have to play a little puzzle game. Okay, and we'll get into that in a minute. All right, so the prefixes go by the number of carbons. As I said the last time, the number of carbons, 1, 2, 3, the prefixes, after 4, penta, hexa, hepta, octa, nona, deca. These are all what we use, same prefixes in covalent bonding, okay? But it's the first 4 that are different. So we have meth, eth, prop, and bute. Again, meth, I write M, eth is E, prop, P, bute, B. So the way I remember the first 4, because I seem to have a block in my mind, is me peanut butter or Mancini eats peanut butter or whatever you like, MEPB. 1 carbon, 2 carbons, 3 carbons, 4 carbons. Okay? And what we did was, we'll just do 1 or 2. Okay, when we did the carbons, right, we said, okay, let's start with 1 carbon. There's 1 carbon. It makes 4 bonds. Okay, and we're doing hydrocarbons, so we're just putting hydrogen there. Okie doke, there's hydrogens. This formula is a CH4, right? 1 carbon, the prefix was meth, right? And single bond, there's no double bonds here, is ane. So this is methane. Okay, and then we said, all right, let's do 2 carbons single bond. Well, there's a carbon hooked to another carbon, right? Remember, carbon makes 4 bonds, so this has 3 remaining bonds, remember? Okay, and we just put our hydrogens here because we have hydrocarbons. H, H, H. We see the formula is C2, H6. Okay, 2 carbons, MEPB, right? E is eth, so the prefix is eth, and is only single bonds, right? So this is ethane, A-N-E. These are part of the alkanes, ethane. And we'll do 1 more, all right? Just to review, 1, 2, 3 is our 3 carbons. That needs 3 more bonds. This only needs 2 more bonds to make 4, and this needs 3 to make 4. Right? So I just put my H's here, hydrocarbon. Okay. Once again, we did this the last time, and I know it's tedious, but it's good to review, right? We could all use a review. Okay, if we write the formula for this, we see we have 3 carbons, and if we count the H's, it looks like 8 H's. Okay, 3 carbons, the prefix was prop. That's 3 carbons. And again, single bonds, the ending is ANE. So there's propane, the gas that's found in barbecues, right? Remember, methane was the gas found in your stove. Okay, and we found a formula for all these alkanes: CH4, C2H6, C3H8, etc. And we said, all right, we watched when we wrote a bunch of these, we found a formula for the alkanes, and they seem to follow this formula. Okay. So the alkanes follow this formula. If you have n carbons, whatever n is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we only go up to 10 for us, all right, then the number of hydrogens is twice the number of carbons, and then add 2, okay? So let's look here. In methane, right, n is 1, there's 1 carbon, right? So 2 times 1 is 2, plus 2 is 4. In ethane, n is 2. So 2 times 2 is 4, plus 2 is 6. In propane, n is 3. 2 times 3 is 6, plus 2 is 8. So if I wanted hexane, okay, hexane, hex is 6. So n is 6. 2 times 6 is 12, plus 2 is 14. So n is 6. 2 times 6 is 12, plus 2 is 14. If I wanted nonane, right? None is, the prefix is 9, right? So n is 9. 2 times 9 is 18, plus 2 is 20. We'll do one more, right? Heptane. Hept is 7, so n is 7. So H is going to be 2 times 7, which is 14, plus 2 is 16. Okay, so we have all the alkanes follow this amazing formula. Okay, so you take twice the number of carbons, and then you add 2. Okay, and remember, this is always an even number. Even number. Okay, well, we did another subclass of hydrocarbons, right? And what we did was, I'll do 1 or 2. If we look at methane, CH4, I'm just reviewing CH4, right? This is methane. CH4, remember? And then I said, oh, let's take away an hydrogen. Take away an H. So now what we have is this, C, H, H, H. But now it's got a free bond. You see, that's a free bond. It wants to bond to something. So this beast is just CH3. We said, notice that's an odd number. 3 is an odd number, okay? And then we played the same game. You know, we did another one. I said, all right, let's look at C2H6. So, right, H, 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 H. There we go. So this, remember, is ethane, C2H6. This was ethane. Again, we're going to take away an H, take away an H, a hydrogen atom. And what we have is C, right? Oopsie. Okay, sorry. H, 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 H. Now again, this has a free bond. So it wants to bond to something. So now we don't have C2H6, we've got C2H5. Okay, and we said again, that's an odd number. And we did a couple of these, and we found the formula for these was almost the same as the alkanes, except for now we have N carbons and 2 times that plus 1 because we took 1 hydrogen away, right? And then we said this was always an odd number, And anything that followed this pattern was called an alkyl. And it's going to have the ending YL. ending YL. So the way I remember it is odd, eel, odd. If there's an odd number, the ending is eel, odd, eel. Okay, so for example, if I want pentyl, okay, pent is 5, C5. So now 2 times 5 is 10. Now we add 1 is 11. So this would be H11. See, it's odd, so it's an eel. If I want hexyl, hex is 6, right? So 2 times 6 is hexyl. Hex is 6, right? So 2 times 6 is 12 plus 1 is 13. Again, odd is an eel. If I want octyl, oct is 8, so I have C8, right? Now I multiply that by 2, I get 16, and then add 1, we get 17. So odd is an eel, octyl, and so forth. So we have the formula for our alkanes, and we have our formula for alkyls. Okay, and then we started naming things. Okay, so let's try to get into some of this. Okay, so again, when I name things, naming compounds, naming compounds. So I'll tell you what I do if I was getting it on an exam. Okay. Okay. Oopsie, sorry. All right. The first thing I do is I find, well, first thing I do is I see if there's only single bonds, and again, we will do double and triple, only single bonds. I'll put if only single bonds, then the ending must be, because it's an alkane, ending must be A-N-E. Okay? So on a multiple choice, if I only see single bonds, anything that's not A-N-E ending is incorrect. Single bonds only has A-N-E endings. The second thing I do is I try to find, because it's not always so obvious, try to find, but you must find, so you don't try, you must find the longest chain of carbon atoms. Chain of carbon atoms. Okay. Now remember, if there's only single bonds, right, this tells you the ending of the molecule. Right? If you find the longest chain, this tells you our prefix. Okay. Well, the next thing we need to do is if I have substitutions. So we have to list the substitutions, And when I say substitutions, we start out with everything hydrogen, hydrocarbons. So we're going to put substitutions for those hydrogens. List the substitutions alphabetically. Alphabetically. Okay. And then really I'll say 4, determine which direction to count. I'll put which direction to count. You'll see what we mean. Which direction to count. Right? Because we're looking for the lowest combination of numbers, as we'll see. Okay, so I'll explain this a little more. Okay, we'll do it with a simple example. Okay, so let's start very simply. Suppose I have this 1, 2, 3, 4, 5. Okay. So we know it's an A-N-E ending because I only have single bonds. That's a good start, right? I'm just going to put H, H, H. That's a good start, right? I'm just going to put H, H, H. And I'm going to put all H's here. Okay, except I'll put something like a bromine here for now, Br. Okay. Well, we know the ending's A-N-E, so I'm going to put A-N-E here because we're so smart. All single bonds. Okay. Next, we count the longest chain. Here it's easy. It's 5, right? So this is definitely pentane. Okay. It's absolutely pentane. Okay. The next thing is we need to look at the substitution. Well, there's only one substitution. It's bromine. Now, if we count from left to right, watch, if we count left to right, this would be carbon 1, this would be carbon 2, this would be carbon 3, this would be carbon 4, this would be carbon 5. So this would be, if we kept this, a 5-bromo pentane, okay? However, if we're on the other side of the molecule, if we were standing on the other side of the molecule looking, we would say, wait, what are you talking about? This is carbon number 1, right? It's on this person's left. This is carbon number 2. This is 3. This is 4. And this is 5. So the green would give us 1-bromo pentane. Well, we have to determine what's a lower number, 5-bromopentane or 1-bromopentane. And the answer is 1-bromopentane, right? So we have to, in this case, count from right to left, okay? Not left to right, okay? Now, this is a simple case, okay? But you must be careful. It's not always so obvious, all right? So we'll do 1 or 2 little problems like this to review. And remember, whatever substitutions I put, we must list them alphabetically, and then we have to say how many there are. So I'll do this 1, 2. I just add a bunch of these. How's this? Okay. I'll put my lines, and then I'll put my substitutions. All right. I'll put some H's here. I'll put a bromine. I'll put a bromine. I'll put a bromine. Okay, I'll put an H. I'm going to put a CH3, CH3, a C2H5, a C2H5. What's he doing? Okay, H, 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 H. All right, so let's see the name of this, okay? First thing we see is that there's all single bonds, remember? So the ending is A-N-E. Next, we have to find the longest chain of carbons. Well, it looks like going straight across. And again, I like to use colored chalk or colored pens or pencils, right? To show my longest chain. So here I'm just going to do it in red. Okay, there's my longest chain. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes, 8, octane. Okay, so this is clearly octane. Okay, no doubt about it that that's octane. Okay, now anything that's not part of my longest chain is a substitution. Okay, so excuse me. Well, it's clear bromine is a substitution, and bromine is a substitution, and bromine, right? Then I've got the CH3 beast. Remember, CH3 is methyl. One carbon and an odd. Odd is eel. CH3, methyl. All right, here's an odd number, C2H5, right? So this 2 carbons is ethyl. Odd is eel. Odd is eel, ethyl. And here, this thing is not part of that red chain, longest chain. This is an ethyl. Odd is eel, ethyl. And here, this thing is not part of that red chain, longest chain. This is an ethyl. Okay, so what do we have? We have, in alphabetical order, we have a bromine. We have ethyl. And then we have methyl. See, alphabetical, B, E, and M. Okay, so now we have to list, excuse me, where they are. Just tell me where they are. First, we have to see which way to count, from left to right or right to left. I think left to right is obvious. 1, carbon 2, carbon 3, carbon 4, carbon 5, and then, okay, we can keep going, 6, 7, 8. So where are the bromines? Well, it looks like there's a bromine on 2, a bromine on 2, and a bromine on 3. So we would write 2, right? Another one on 2, and then one on 3. Since there's 3 bromines, we would write tri for 3, bromo. Okay, we took care of the bromines. Now, where's the ethyl? Well, the ethyls seem to be on carbon 5, right? Here's an ethyl, and there's an ethyl. So we would write 5, 5, diethyl. Okay, so we took care of the ethyl. And then finally, we have the methyl. Where's the methyl? Well, methyl is on carbon 4, and the methyl is on carbon 4. So this would be a 4, 4 dimethyl. Octane. Okay. So once again, how do we name this? We see all the single bonds, so we know the ending is ANE. We count the longest chain of carbons, which was 8. So we have octane. Then we list what our substitutions are, and I like to circle them because they're not part of that red longest chain. And so we have the bromine, the ethyl, and the methyl. And next, we just list where they are, which carbon. We have to determine whether to count from left to right or right to left. Okay, and I think this is obvious that left to right is the way to go. Okay, so let's do a couple more of these. Practice. All right, suppose I give you something like this. C2H5. How's this look? I'm sorry, I'm so slow. All right, let's put a C2H5. All right, so, wow. Oh, let's put an H here. It doesn't matter. I'll put a CH. C2H5. How's that? Let's just really make this bizarro. Okay, so first thing we notice, once again, it's all single bonds. So I know the ending is A, N, E. The second thing we need to do, and you should do this, you should pause now, and you should try to do it, is find the longest chain of carbons. Find the longest chain of carbons and see if you agree with what I get. Okay? Oops, sorry. I didn't complete this right. Okay, so it's C5H11 there, right? It's got to be that. Okay. All right, so the longest chain, hopefully you found it yourself, there's 5 carbons. If I go here, 6, 7, 8, 9, 10. I believe this is my longest chain. Okay? And I believe that I'm going to count down and count this way. Okay? So if that's 3 carbons, that's 3. This would be carbon 4, and this would be carbon 5. And then there's the other 5 to make decane. Okay? So this is definitely decane, I believe. Okay? The next thing we have to do, remember, anything that's not part of that red line is an addition. So this beast is an addition. C2H5 was ethyl. Okay. Oh, look, there's another ethyl. And look, this whole thing here is not part of that chain, is it? This whole thing is not part of that chain. Well, how many carbons are there? There's 2, 3. Here is not part of that chain, is it? This whole thing is not part of that chain. Well, how many carbons are there? There's 2, 3, 4, right? And so we have C4. How many hydrogens? 6. Wait, how many? Oh yeah, 4. Right. No, 5. Sorry. 1, 2, 3, 4, 5. Sorry. Old man forgot the main carbon in the middle, right? Okay, so it's C5. Count all those hydrogens. 5 plus 3 plus 3 is 11. C5H11. Remember, odd is eel. The ending is eel. 5 is pent. So this is pentyl. Pentyl. Well, we didn't do all the additions. I still have this guy. Okay, this has 1, 2, 3. This is 4 carbons. Right? 4 carbons. And if we count, we have 9 hydrogens. 4 carbons, remember the prefix is but, odd is eel, so this is butyl. Okay, so let's list these additions alphabetically. Okay, so first we have butyl, B. Next, I guess we have ethyl. And then finally, we have this pentyl. I think that covers everything, pentyl. Now, we just got to tell you where they are. Now, I've already numbered the sites, right? So let's see. Where is the butyl? Well, here's the butyl, and it's attached here to carbon 4. There's only one butyl, right? So this would be a 4-butyl. Okay, what comes next? Okay, so we did the butyl. Let's do the ethyl. Ethyl, where's the ethyl? Well, there's an ethyl here on carbon 4, and there's an ethyl here on carbon 5, right? So it looks like we have a 4,5 diethyl, because there's 2 of them. And then finally, so we did the ethyl, good for ethyl. Now we do the pentyl. Where's the pentyl? Here's the pentyl. It's attached here to carbon 5. So this would be a 5-pentyl. Decane. Okay, so we just drew 4-butyl, 4,5-diethyl, 5-pentyl decane. Okay. All right. So once again, we started with the ending. We noticed it was all single bonds, so we know it's an alkane. And so we put the ending ANE. Then we looked around, and I found, I believe, is the longest chain, which is 10. So I know it's decane. And then I made, in red, I colored in that long path, right? So those are the carbons involved in my longest chain. Anything not part of that red longest chain is an addition, and those are the things that are circled in green. So I have a C2H5. Again, it's odd. 5 is an odd number, so I know the ending's -yle. 2 carbons, the prefix is eth, so this is ethyl, and there was a carbon there, ethyl on carbon 5 and one on 4. Then this big mess, right? There were 4 carbons and 9 hydrogens, right? And we know that's a butyl. Again, odd is yle. Remember, all the yles want to make one bond. And then finally, we counted the carbons on the left side, and we found it was a pentyl because there was 5 carbons and 11 hydrogen atoms, and that's pentyl. Okay, and we listed them, and then we put them alphabetically. We saw which carbons they were on, and we found it was 4-butyl, 4,5-diethyl, 5-pentyl, decane. Okay, we're so brilliant, aren't we? Brilliant. Okay, all right. Let's try another one. Okay. Again, I make these up in my head, right? So forgive me. All right. Let's see if this works. Okay. All right. So once again, we have the ending, right? We know the ending, all single bonds. I think I got everything there. So the ending is ANE. Okay, ANE. Now we have to find the longest chain. Well, here's where you should pause and try to find the longest chain and see if we agree on what the longest chain is, okay? So you try to do it and I'll try to do it, okay? I think I see it. Oh, did I do it? Hold on. I don't think I did what I want. Okay, I didn't do what I want. All right, let me fix it. Okie doke, this is what I want. C2H5. All right, now I think I have what I want to do. Okay. Sorry, I was rushing. So I believe we have 4 carbons there. There's 5 carbons. Go up here. There's 6 carbons. If I go up, that's 7. If I go to the left, it's 8, 9. If I go 4, 5, 6, 4, 5, 6, 7. You know what? Again, I'm going to change this again. I'm sorry. Okay. I'll make this a C3H7. Okay. C3H7. Okay. Sorry, I miscounted on this one. Okay, so here again, this one, I think, I don't want you to be confused, too confused anyway. I think it's decane. 4 is 4, 5, 6, 7, 8, 9, 10. Okay, so I think that's my chain. I don't think there's any other decanes here. Okay, so there's my longest chain. Now, remember what we have to do is we have to find anything that's not attached to that is an addition, right? So find anything that's not attached to that is an addition, right? So this is not part of it. This whole thing is not part of it. You see how the colored marker makes a difference. This is not part of it, and this is not part of it, okay? Okay, well, this is a CH3, so that's methyl. Eel, remember, eel is odd. 3 is prop, so this is propyl. Okay, CH3, methyl. And here, how many carbons got? 1, 2, 3, 4. Is that right? 4 carbons. So this is C4H, right? 9. And 9 is eel. 4 carbons is but. So here's my butyl again. Okay. So our additions are butyl, methyl, and finally propyl. Okay, all right. Now what we have to do is determine which way to count. All right. Geez. I believe if we start from the bottom, this is carbon 4. That would make this carbon 5, carbon 6. If we start at the top, this is carbon 3, carbon 4, carbon 5. So I think I'm starting here. This is going to be carbon 4. You know what? I'll do a different color, okay? So that's carbon 3. This is carbon 4. This is carbon 5. And this is carbon 6. Okay, so now I can see where the additions are. Okay, so first comes butyl. So it looks like butyl is on carbon 5. So we have a 5 butyl. Okay, next comes methyl. Where's the methyl? Well, there's a methyl on carbon 5. And, oh, sorry. Do I have 2 butyls? Sorry. No, this is a methyl. Okay, so methyl's on 6. So I have a 5,6 dimethyl. 5, 6 dimethyl, right? Because here's a methyl, and it's connected to carbon 6, and here's a methyl, it's connected to carbon 5. And then finally, we have the propyl. See the propyl here. Then it would be a 6 propyl decane. Okay, sorry, sometimes when I make these up, I have to be very careful not to make them too cryptic, because there's many ways to interpret some of them. Okay, and if I just do them off the top of my head, sometimes it's not so good. Right? Let me show you something else before we go on. Okay, I'm just going to review for a second. So watch. So let's look at ethane. Okay, so ethane was C. H, 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 right? It was C2H6. Okay. I could write this. Okay, look at this. Look at the ending. See, you have a CH3 here. And here we have a CH3. So I can write ethane as CH3, CH3. 3. See, that's ethane. 2 CH3s hooked together. Okay. Now, if we do propane, remember, propane has 3, so it's C3. Odd is yield 2N plus 1 is H7. So we're going to put 3 carbons together. Oh, why'd I do that? 8. I want propane, not propyl, sorry. 1, 2, 3. Okay, so we're just going to fill this in with our H's. Okay, so let's look at this beast. Okay, well, once again, on the end, we have a CH3. On the end, we have a CH3. And in between, we have a CH2. And in between, we have a CH2. Okay, CH2. All right, I'll clear that and just rewrite it. Okay, I'll rewrite this whole thing so you can follow it a little better. Okay, so on the end, we have a CH3. In the middle, we have a CH2. And on the end, we have a CH3. Okay, let's do the next one. Well, me peanut butter, so let's do butane. Butane. Right, so it's Cn, N is 4, 2N plus 2, 2 times 4 is 8, plus 2 is 10. So we're going to do 4 carbons. Okay, 1, 2, 3, 4. And we're just going to make it a hydrocarbon. We're just going to put our H's again. Very slow, very deliberate, so you can follow. Okay, so what do we have? Well, once again, if we follow what we've been doing, on the end, notice we have a CH3. Here, CH2. Then we have another CH2. And then on the end, our CH3. Okay, we'll do one more because I think you're getting the idea, right? So let's do pentane. Okay, so pent is 5. So we know the formula is C5. And ane is 2N plus 2. 2 times 5 is 10, plus 2 would be 12. So let's do this quick. 1, 2, 3, 4, 5. There's my pentane. Just put our H's here. H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and there's our 12. Beautiful pentane. And once again, we play this game, right? So on the end, notice we have a CH3. Then we've got a CH2, a CH2, and a CH2, and then a CH3. So we have a CH3. Then we've got 3 CH2, 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 and then finally CH3. Instead of writing the CH2 3 times, we can write this as CH3, CH2 3 times, and then CH3. Okay, so if I saw this on the test, this is pentane. See the way I wrote it? The same for butane. Okay, if I have butane, we can write this as, since we have two CH2s, this could be written as CH3, CH2, two of those, and then CH3. Here we just have one CH2, and here we have no CH2. Okay, so these are fine. Okay. So this shortcut, writing this, the molecule this way, how can I figure out what this is? If I gave this on the test, the question is, how in the world could we figure out what that is? Okay, well, let's try to do a couple of these. Let's see if we can work this out together. I'll do one example, a straightforward example. Okay, so let's do this. 1, 2, 3, 4, 5. Well, let's just say I do this. Okay, 4, 5. Well, let's just say I do this. Okay. So we can see right away, this is what? Pentane, right? Suppose I put a CH3 here now. H, H, H. Okay, now it doesn't matter if I go left to right or right to left. This is definitely a 3-methyl, CH3 is methyl, pentane. Doesn't matter, left to right, right to left, doesn't matter, because it's right in the middle. Okay, so what? Okay, well, what I want to do is I want to write it in that condensed form. So watch what I'm doing. I'm going to write CH3. Okay, so we took care of this part. Then we have a CH2. Okay, so we took care of this part. Now I have a C, an H, and a CH3. Okay, then we have the CH2. And then we have, oops, sorry, I forgot my H's, sorry. Then we have a CH3. Okay, so this, if I gave this on the test, you would have to unpack this, right, to figure out when you draw it that you get a 3-methylpentane. How do you unpack it? Okay, so we'll do something like this. Okay, so let's clear this, and I'll give you an example, and we'll try to unpack it together. Okay, so let's write. Here we go. All right, let's see if we can do this mother, okay? All right, so we want to unpack this. Ha! Okay, so we want to unpack it. Unpack it so we can name it. Okay, so let's go together. Here we go. There's a CH3. C, H, H, H. Okay, I did that. Now here's a CH2. C, H, H. Good, we did that. Oh, another CH2. C, H, H. Okay. Well, another CH2. C, H, H. Now we have a C. I'm going to put that C there. Now we have what? A CH3. Oops, I forgot an H there. Okay, so this should be an H. There's an H. again, sometimes I'm a little sloppy. No, I don't want the H. I don't want the H. I don't want it. I did exactly what I want. So I have a CH3. Let me erase this. Sorry, I did exactly what I wanted to do. Okay, so I have the C. Now I have a CH3 attached to it. This CH3. But now I have another CH3. Look. Now I have a CH2. Okay, then I have a CH. H. Now I have a CH3. H. Now I have a CH3. Okay. Now I have a CH2. H and an H. And then finally a CH3. Whew. Wow. Wow. Okay. So now we need to find the longest chain. Okay. Well, the longest chain looks like here, right? Looks like straight across. Okay, so that's what? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is definitely no name. Okay, now we have to look at whatever the additions are. Well, there's an addition, there's an addition, and there's an addition. So we have a trimethyl. Okay, so where are the methyls? If I count right to left, that's 1, 2, 3, so it would be 3, 5, 5. If I count from left to right, it's 1, 2, 3, 4, 5. It's 5, 5, 7, 7. So I think I count left to right, right? So that gave me a 3, 5, 5 trimethyl nonane. I think that's the name of that one. Okay. Wow, that's really something. All right, let's do another one. Okay. Let's do another one of these unpacking ones, okay? So let's see, I have CH3, CH2, CH2, CCH3, CCH3, CH3, okay, CH2, CH3. Okay, so we'll do something very similar. All right, so here we go. All right, here we go. We want to undo this stuff, right? So let's see. So here we have a CH3. There's a C, H3. Okay, we took care of that. Now we have a CH2. There's a C, H, H. Very good. All right, next we have another CH2. C, H, H. Good. Now we have a C. But now we have a CH3. Right? There's a CH3 right here. But then we've got another CH3. Okay? Now we've got a CH2. And then we've got the CH3. Okay, so it's clear. I think it's clear. Our longest chain is right across. 1, 2, 3, 4, 5, 6. So this is definitely hexane. Longest chain, right? Now, what do we have to do? We have to look at anything not attached to that, right? That not part of the longest chain. Well, there's a methyl, and here's a methyl, right? That's methyl. And here's a methyl. And I think, right, we should count left to right. So this is carbon 1, carbon 2, carbon 3. So it looks like a 3,3 dimethyl hexane. Okay, let's do one more. All right, since we're having so much fun. Let's do another one. Okay, so let's see if I can get this right. Okay, let's see. All right, so here we go. We're going to have CH3, CH, CH3, CH2, CH3, CH2, H2, sorry, CH, C2H5, okay, CH, CH3, CH2, CH2, CH3, CH2, CH2, CH3. Wow, what a beast this looks like. All right, well, let's just go slow and unpack it together, okay? So here we go. We have CH3. Okay, so we took care of this beast. Now we have a CH and a CH3. So there's a C, an H, and there's my CH3, my methyl. Okay, so we did this. Now we have a CH2. Now we have a C and H, a C and H, and now we have a C2H5 and ethyl. Okay, so we took care of that. Now we have a C and H and a CH3 again. Okay, so we took care of that. Now we have CH2, 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 and then finally the CH3. Okay, so once again, so now we unpacked it. Now we just count the longest chain. Well, there's 1, 2, 3, 4, 5, 6, 7, 8. So this clearly, I believe, is octane. Once again, longest chain is oct. All single bonds, the ending is ane, right? We're doing alkanes. Now we look at whatever's not part of that is an addition, right? So CH3, we're getting to be experts on this, is methyl. C2H5 is ethyl. And here's methyl. So let's see, if I count to 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. All right, so I think I have to count left to right. So it's carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Okay, so it looks like a 4 ethyl, 2,5 dimethyl octane. 4 ethyl. Okay, that looks good. Very good. Very good. Wow. Boy, is this hard. Okay. All right. Enough unpacking for now. Let's go back. Let me give you something like this, okay? And again, I ask you to try it before I start naming it, okay? Here's a fun one. Fun one. Okay, all right. Well, we know the ending. The ending's ANE, right? Now you should pause and try to find the longest chain before I do it, okay? Try to find the longest chain, and then we can do it together. Okay, hopefully we will agree, okay? I believe it's decane. So there's 4, 5, 6, 10. Okay, so there's 4 carbons, there's 5 carbons, 6, and 4 more is 10. So I believe the longest chain is decane. Okay, that means, remember, anything not part of that red longest chain is an addition, right? So what do we have? This thing is not part of it. Okay, this is not part of it. This is not part of it. And this whole thing here is not part of it. Okay, so we got to figure out what these things are. Okay, now again, odd is eel, 3 MEP, so this is a propyl. Okay, well, C3H7 is another propyl. C3H7 is another propyl. Okay, and this beast, well, we have 2, 3, 4, 5, 6, 7. So there's 7 carbons here, and it's an odd number. There's 15 hydrogens. So odd is eel, 7 is hept. So this is heptyl. Okay, so our additions then are heptyl and propyl. Heptyl and propyl. So we have to list these alphabetically, right? Propyl. Okay, so the question is, do we count from down to the top or top to the bottom? Okay, well, heptyl comes first. So if I count from the bottom to the top, so let me do bottom to top first. Bottom to the top. Okay, that would make this carbon 5, right? So that would be a 5 heptyl. Okay, and this would be carbon 6, right? And so it would be a 5, 6, 6, 5, 6, 6 tripropyl. Okay. Now let me do a different color. Let's do I'll do black. Okay. Let's do black. Let's do from top to bottom. Let's see what the numbering gives us. Bottom. Sorry. Okay, this would be carbon 4. So this would be carbon 5. This would be carbon 6. Okay, so let's see. So where is the heptyl? Now the heptyl would be on 6. So this would be a 6 heptyl. And where were the propyls? Well, there's a propyl on 5, 5, and 6. 5, 5, 6. Tripropyl decane. Okay, so I did one. Wow, it's not so obvious, is it? Which is lower? 6-heptyl 5,5,6 tripropyl decane, or 5-heptyl 5,6,6? Probably I would go with this because it starts with a lower number, but it's close. Okay, so I'm not, if I don't think them out beforehand, sometimes it's not obvious, but I think I would go with the 5-heptyl. Okay, I would go with the 5-heptyl. Good, good. We're becoming world experts on this stuff, right? Let me introduce double and triple bonds, okay? So let's consider double bond. So we're going to consider a double bond, one double bond. Okay, and we're going to find a formula very quickly, okay? Okay, so you can't have a double bond with one carbon, right? So we're going to do a double bond with 2 carbons. There's double bond. Now remember, carbon makes 4 bonds, so this has 2 free bonds. Okay, so we're going to put an H, an H, an H, and an H. And we'll write the formula. This looks like C2H4. Okay, we're not naming it yet. I do know the prefix is going to be eth. How do I know it's eth? I'm going to write eth. 4. Okay, we're not naming it yet. I do know the prefix is going to be eth. How do I know it's eth? I'm going to write eth. How do we know it's eth? Well, we know the prefix is eth because there's 2 carbons in the longest chain. The prefix does not change. Okay. All right, let's do 3 carbons. I'll just put a double bond here, here, and here. Okay, there's 3 carbons. Now, this first carbon has 2 remaining bonds. 1, 2. This carbon in the middle is already making 2 bonds, and 1 is 3 bonds, so it only has 1 free bond, H. Doesn't matter if I put it on the top or bottom. And this guy still has 3 free bonds, H, 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 right? So this formula looks like 3C3H6. Okay, and again, we know the prefix, three carbons, is going to be prop, but we don't know the ending yet. We're going to name these in a second. Okay, let's do one more. Okay, because the pattern is almost clear. Okay, we're going to do 4 carbons. So there's 1. I'll just put the double bond here. 2, 3, 4. Okay, once again, the first carbon has 2 remaining bonds. The middle guy has 2, 3. It's got 1 free bond. This guy's got 2 free bonds, and this guy's got 3 free bonds, right? Because it has to make 4. So let's just put the H's in. Okay, if we count the carbons, we have 4 carbons. And how many hydrogens? Well, we got 3, 6, 7, 8. Oh, look at that, H8. Okay. Once again, we know 4 carbons. The prefix will be but. Okay. But the question is, what is the pattern and what is the ending? Okay. Now, when we have double bonds, we have 1 double bond. We're just doing a single double bond. These are called, not the alkanes, these are called alkenes. E-N-E-S. Enes. So they all end in E-N-E. Okay, that's our ending. So we know the name of this guy is going to be eth. 2 carbons is eth. This is ethene. Okay, 3 carbons is prop, right? But we have the double bond, so this is propene. 4 carbons we said was but. Now the ending is butene. Okay, and if we look, I think it's obvious, we see the formula. If we have n carbons, if this is 2, this is 4. If this is 3, this is 6. If this is 4, this is 8. So the formula for the alkenes is C sub n, and then we just have twice that number, 2n, right? If n is 2, H is 4. If n is 3, H is 6. If n is 4, H is 8. Okay? So if I ask you, for example, what is the formula for pentene? Well, pent is 5, and then we just take 2 times that is H10. If I want the formula for octene, well, 8 is oct, and then ene means you take 2 times that, H16, right? Hexene, right? Hex is 6, and 2 times that is 12, right? Heptene is C7, H14. Wow, that wasn't so bad, the double bonds. I'm gonna show you that double bond and triple bonds actually naming are very, very easy. You'll see what I mean in a second. Okay, so let's now get the triple bonds because we're so smart now. Okay, so now let's look at triple bonds. Get the triple bonds because we're so smart now. Okay, so now let's look at triple bonds. So we want to look at a single triple bond, okay? And then I will tell you how to name things, okay? Better. All right, so once again, you cannot have a triple bond with 1 carbon. So we have to do 2 carbons to start. There's a triple bond. Now remember, carbon makes 4 bonds. So this guy's only got 1 free bond, and this guy's got only 1 free bond. Don't worry about top or bottom. So it looks like this is C2, H2. Remember, 2 carbons, the prefix is going to be S. We got to get the ending, okay? So now let's do 3 carbons. So let's do a triple bond. Okay, this first guy has a free bond. The middle guy makes 3 and 1 is 4. So the middle guy, that's it. Can't make any more bonds because it only makes 4 bonds. And then we have this, H, H, right? So it looks like this thing is going to be C3, H4, right? Now we know 3 carbons. The prefix is prop. So all we know is this is going to be a prop. Okay. Let's keep going. Let's do another one, and then I'll tell you the pattern, okay? Because they all have patterns. So here's a triple bond. Now we'll do 4 carbons, okay? This guy still has 3 bonds to make. This guy's got 2. This guy, right? This guy next to the triple bond has no more. He's got 3 on the left and 1 on the right, so he's got no more. And this guy in the end only has 1 free one because he's making a triple bond, okay? So if we look at the formula of this, oops, let's put the H's in. Sorry. H, 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 H. Okay, so this looks like 4 carbons. Count the H's. It looks like 6. Okay, and then we say over here, is there a pattern? It turns out is there a pattern? Is there a pattern? Right? A pattern means we want an equation to be able to determine these, like we did with the alkanes, the alkenes, and the alkyls. Right? Is there a pattern? And of course, the answer is yes. Okay, when there's a triple bond, the ending, as we'll see, is going to be YNE. Okay, these are the so-called alkynes. Alkynes. YNES. So there's my ending is YNE. Okay, so the ending is YNE. So 2 carbons is eth, so this would be ethyne. 3 carbons is prop, this would be propine. 4 carbons is bute, so this would be butine. Okay, now I'm going to give you the formula. It's not so obvious. The double bonds was easy, right? Alkenes was CnH2n. So here the formula is going to be C. If there's N carbons, then the number of hydrogens is twice that, but then subtract 2. Okay, so let's look. Here, I'll do a different color, okay? Here, N is 2. 2 times 2 is 4, minus 2 is 2. Here, N is 3. 2 times 3 is 6, minus 2 is 4. Here, 2 times 4 is 8, minus 2 is 6. So if I want the formula for hexene, hexine, right? It's hex is 6. 2 times 6 is 12, minus 2 is 10. If I want the formula for decine, well, dec is, if I want the formula for decine, well, dec is 10. 2 times 10 is 20, minus 2 is 18. Octine, well, oct is 8. 2 times 8 is 16, minus 2 is 14. Heptine, well, hept is 7. 2 times 7 is 14, minus 2 is 12. Okay. Nonine. Nonine. So this is 9. 2 times 9 is 18, minus 2 is 16. Okay, and pentine. We'll do pentine, last one, okay? Pentine. Okay, well, pent is 5. 2 times 5 is 10, minus 2 is 8. Okay, well, that's that. But let's see. I remember I kept saying doing double and triple bonds are actually easier than single bonds. So let me show you what I mean. Okay, first let me show you this. Let's do this first. So let's do 1, 2, 3, 4, 5. All right, we'll just do this. Sorry, I'm so slow. Again, I know my H's look a bit like 4s. I don't mean that to be the case. Sorry, but you can understand by now, right? H, H, H. So the longest chain has 5, and there's a double bond, right? So double bond is ine. So this is definitely pentine. Okay. Okay. Good. Now watch what I'm going to do now. 1. Oops. It's absolutely not correct what I did, my pentine. Boy, am I dumb. Look at that first carbon. You see it's making five bonds. Can't make 5 bonds, right? The middle one can't make 5 bonds. It's got 2, 3, 4, 5. So we got to take this out, right? Does everybody see that now the first carbon makes 4 bonds, the second carbon makes 4 bonds? Okay, so Mansinitsky screwed up there. All right, so again, let me be careful with what I want to do. Okay, so I'm going to put a double bond here. Okay, so H, 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 okay? Well, this is also pentyne, okay? But they're different. These are not the same pentynes. Why are they different? Because of where the double bond is. Now, I know I said when we first started organic chemistry is very sensitive to which carbon the substitutions are, and also which carbons now these double bonds are going to be on. So again, I'm making this up. The first one I drew here with the double bond is on carbon 1. This would be carbon 2, carbon 3, carbon 4. Carbon 5, okay? And here we start here 1, 2, 3, 4, 5. Okay, this one with the carbon on carbon number 1, this chemical, this pentyne, could be again a brown poisonous gas. And this one with the double bond on carbon 2, we picked the lowest number, could be a sweetener for your coffee. So they're very different. So what we have to do is tell you where the double bond is. So this would be called, because of where the double bond is, a 1-pentyne. The second one would be a 2-pentyne. Okay. Now, this is very important because this is what makes it so much easier. Wherever the double bond is, or the same will hold as we'll see for the triple bond, wherever the double bond is, this determines how to count, how triple bond, wherever the double bond is, this determines how to count, how to count. Okay, so if the double bond is here, that forces, because that would make this a 1, the lowest number, a 1-pentyne, right? Because it's on carbon 1. Now, even if, now watch what I'm going to do. I'm going to make this a little, suppose I had a bromine here. Suppose I put a bromine here and I put a bromine here. Well, we know alphabetically we'd want to say, oh, that's carbon 1 because there's a bromine here and a bromine here. We'd want to make that carbon 1. We'd want to make that a 1,1 dibromo. But what I just told you was wherever the double or triple bond is, that determines how you count. Once the double bond is there and you could find the lowest carbon, then that means we must count this way. So this is not a 1,1 dibromopentine, 1-pentyne. This is a 5,5 dibromo. So once you have a double bond, right? Again, if there was a bromine here, this would be a 5-bromo 2-pentyne, okay? So wherever the double bond is, find which the lowest carbon that's attached to, and that tells you where you must count, which direction. So let's do another one. Let me illustrate this again, okay? Let's just look at this guy, okay? So first thing we do is we find the longest chain. And it looks like the longest chain is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's definitely 9. And I see a triple bond there, right? So this is definitely known is 9. Triple bond is ein, no 9. Definitely no 9. Now we have to find out where is this triple bond? Which is the lowest carbon? Well, it's clear that if we count from right to left, this is carbon 1, this is carbon 2, and this is carbon 3. So this forces us to count from right to left. Okay, so that means this is carbon 4, this is carbon 5, This is carbon 6. This is carbon 7. This is carbon 8. And this is carbon 9. Okay. So because the triple bond, the lowest carbon is 3, carbon 3, this would be a 3, no 9. Now, I don't have to, now I just look at where the additions are. Okay. Because the direction has already been determined by where the placement of the triple bond. Okay. So here's a bromine and a bromine. So this looks like a 6,6 dibromo. And then we have a methyl, and a methyl. So that looks like a 5,5,7, 5,5,7 trimethyl. 3, no 9. The 3 tells us where the triple bond is. Once again, where the triple bond or the double bond is determines what direction we need to count. Okay? So let's do another example. All right. Now, whenever we do the longest chain, I'm just going to write this. Whenever we do the longest chain, whatever I do, the longest chain, when we count, must must have in it, okay, the double or triple bond, the double or triple bond. Okay. Okay, you'll see what I mean. All right. So the double, if there's a double or triple bond, that has to be part of your longest chain. So let's do one of our little things here. Okay. One. So let's do this example. All right, almost done. Here we go. Okay, here's where you should pause, right, and try to find the longest chain. First of all, first thing I want you to notice is there's a double bond, right? So I know the ending must be E-N-E because of the double bond. Double bond is E-N-E, right? Now the double bond must be part of the longest chain, right? And I think that this is our longest chain. Okay, and I think that's 9. So I believe this is nonene. Okay, now where is the triple bond? Well, if I count from the top down, that would be carbon 3, 4, 5. That would be a 5, right? But if I count from the bottom, this is 3, 4. So I'm going upwards, because that gives a lower number. So this is definitely a 4 nonene. Okay, 4 nonene. So if that's carbon 4, this is carbon 5. Remember, the double bond, you don't have to look at anything else. The double bond tells us the direction, and this would be carbon 6, right? Once again, anything not part of my longest chain is an addition. So there's a C2H5, our old friend ethyl. Okay, all right, we've got this beast. Woo! What is it? Oh, well, 1, 2, 3, 4 carbons and 9, right? So it's C4. right? That's but, and H9, right? It's odd, so this is butyl. Okay, and then this whole thing, this thing is not part of our chain. Well, that's C2, H5, right? C2, H5 is our ethyl. Did I get everything? Looks like I got everything. All right, so we have a butyl and an ethyl. Butyl comes first, and then the ethyl. Okay, so where's the butyl? Well, we had to count from the bottom. Remember, we had to count going upwards because this was carbon 3, carbon 4, and making that a 4-nonene. We have to count up. So it looks like the butyl, right, is on carbon 6, right? So this is a 6-butyl. Now, where are the ethyls? Well, there's an ethyl here on carbon 5 and an ethyl here on carbon 6, right? So we have, what did I say, 5, 6, 5, 6 diethyl. Okay, so you see the double bond, once you find where the lowest carbon is for the double bond or triple bond, that's the direction you must count. Okay, so after that, it's pretty easy. Okay, well, I guess that's enough. I think once again, your heads are probably exploding from all this. But before we finish, I'm going to do a little summary of naming, okay? So remember, I'm just going to summarize the formulas. Remember, alkanes, the formula was N carbons, and then we had 2N plus 2. Alkyls, remember, eels is odd, and then we had 2N plus 2. Alkyls, remember, eels is odd, alkyls, methyl, propyl, butyl, and all that stuff, alkyls, right? It was CN. We took away a hydrogen, so it was H2N plus 1. And then we did the double bonds, alkenes. Okay, and that was simply N carbons, and then there was just twice the number of hydrogens. And then finally, the triple bonds were alkynes. Right, that was N carbons, and then number of hydrogens, double that, and then subtract 2. Okay, so on the exam 3, and on the final, I will give you things like this. So we want to name certain things, okay? So I'll say name. Okay, and we'll go over these. And again, you can pause this once I write them all right? H12, C9, H20. uh, 16. All right, so you should pause and see if you can name these, okay? And then we'll do it together now, okay? Well, first one, I have 5 carbons, so I know the prefix is pent. This is an odd number, right? So I know I have 2 times 5 is 10 plus 1. This is pentyl. Okay. Here we have 6 carbons, so we know the prefix is hex. 2 times 6 is 12, so N, 2N, N, 2N is ene, hexene. Okay. Here we have 9, so we know the prefix is non. 2 times 9 is 18, plus 2 is 20, so that's nonane. Right? 3 carbons, remember me peanut butter, remember the first 4, MEPB, methyl ethyl prop, meth eth prop bute, right? So 3 carbons is prop, so the prefix is prop. 2 times 3 is 6, minus 2 follows the alkynes, so this is propyne. Here we have 8. 8 is oct. So N is 8. 2 times 8 is 16. So it's N, 2N. N, 2N is octene. ENE ending. It's an alkene. Okay. Here we have 2. Remember, 2 is eth. 2 times 2 is 4. But when you remember, 2 is eth. 2 times 2 is 4, but when you subtract 2, you get 2. So 2N minus 2, this is ethine. Okay. Here we have 7. 7 is hept. 2 times 7 is 14, plus 2 is 16. So that's an alkane. So this is heptane. Okay. Here we have 10. So the prefix is dec. 2 times 10 is 20 plus 1. Again, that's odd. Remember, odd is an eel. So this is decyl. Odd is eel. All right. And here we have oct again. 2 times 8 is 16 plus 2 is an alkane. So it's octane. Remember, octane is gasoline. It's what you put in your car. Octane. Okay. I have C2H2 too many times, right? So let's just change that to C2H6. Okay. All right. Well, N is 2, so we know the prefix is eth. 2 times 2 is 4 plus 2, ethane. Okay. So what we have to do is try to remember these formulas. 2N plus 2, the ending is ANE. Oopsie. Sorry. ANE. Right? If it's 2 times the number of carbons plus 1, remember odd, the ending is eel. If it's N, 2N, the ending is ENE. And if it's 2N minus 2, the ending is YNE, the alkynes. Okay. All right. And so on exam 3 and also on the final exam, I will give you, for example, what is the name of C5H8? Well, right away, that's pent. 2 times 5 is 10, minus 2 is 8, so this would be pentyne, right? Pentyne, okay, etc. So you'd be able to hopefully name these things. All right. Hopefully you can digest a lot of what we've done today and hopefully understand something. All right. See you next time.